In this video, we're going to learn about velocity. We'll cover what velocity is, what units we use to measure it, the equation for velocity, how we can find velocity from a position versus time graph, and how to solve velocity problems. Velocity is defined as the change in position over time. The variables here are v for velocity, delta x for change in position, and t for time. The equation is v equals delta x over t. Velocity can be measured in many different units, but typically in physics we use meters per second. It's important to remember that velocity includes both the speed and the direction that an object is moving. If we look at a position versus time graph, we can read the velocity from the slope of the graph. Remember that slope is the rise over run of a line, and velocity is the change in position over time. So the slope equals the velocity on this graph. If there's a steeper slope, like the blue line, that means a higher velocity, and a flatter slope like the red line means a lower velocity. If you look at the graph, you can see that at 4 seconds, the red line has only represents movement of 2 meters, but the blue line represents movement of 8 meters over that same 4 seconds. So the blue line represents an object that's moving faster than the red line. If the line has a negative slope, that means the object is moving backwards towards where it started. Let's look at some velocity problems. Remember our equation, velocity equals delta x divided by t. In our problem, Jerry walks from 0 meters to 7 meters on this number line. So he's moving to the right. He takes 3 seconds to move. We want to know what Jerry's velocity is. For this problem, we're going to use the QUES system. Remember, QUES stands for knowns, unknown, equation, substitute, and solve. In our problem, we have several knowns. We see that Jerry moves 7 meters from 0 to 7 meters on the number line, and we know that it takes him 3 seconds to do it. Those are both known values from the problem. The unknown we're solving for is velocity. And of course the velocity equation, v equals delta x over t. Substituting delta x and t into the equation, we get v for velocity equals 7 meters divided by 3 seconds. Using a calculator, we can find that the velocity is 2.3 meters per second. Let's look at another example. In this case, Sarah starts at 5 meters on the number line and skates to -8 meters. So she's moving in a negative direction. Sarah takes 4 seconds and we want to know her velocity. Using QUES again, our knowns are delta x is -13 meters. Time is 4 seconds. We're solving for velocity again, using the velocity equation. Substituting -13 meters for delta x and 4 seconds for time, we can calculate that Sarah's velocity was -3.25 meters per second. In this lesson, we saw that velocity is the change in position over time, and that velocity is usually measured in physics in meters per second. Velocity includes both the speed and the direction of the object that's moving, and we can find velocity using the equation v equals delta x over t. We saw that the slope of a position versus time graph shows us the velocity of the moving object, and we looked at how to solve velocity problems using QUES.